G'day and thanks for joining me for this spin launcher question. So we've got this disc that's spinning around on a horizontal plane. We've got a little projectile on it. Maybe some little pin drops out and that allows the projectile to head off. And our first question asks us, which trajectory does it follow? Now, you might be aware of, if not, have a look at this cool video on YouTube by this physics guy. And he uses this amazing bit of apparatus to actually measure what happens. And what he finds is that for an object out here connected by some sort of string or something like that to the center body and it's orbiting like this, if we release it from this point here, its trajectory is actually like A. It takes time for the wave of compression or tension in this case to transfer down, to move down that, whatever that object, that string or the spring is. And so while that is there, there's still going to be a centripetal force on the object, and so it does actually follow a path like A. It's not that dissimilar. If you haven't seen it, check it out on Veritasium. The slinky drop, right? If you hold up a slinky and you release it, the top starts to fall, but while the bottom remains there, it takes time for that wave to travel down until that wave hits that bottom. That bottom part is still connected by a bit of spring in tension holding an upwards force on it. That's why it doesn't start to accelerate down at G. The center of mass does, but of course that whole thing doesn't. This is not that kind of question because it's not a projectile connected by a string. It's on a disc and something kind of releases it, and so there isn't that time. That isn't the requirement for that time of that wave to propagate out to it. So that it does actually make the right answer B. Probably made a kind of meal of all of that, but it's important to be aware that physics is really cool, and in real situations kind of weird things happen that we don't necessarily expect, and it's not always the answer that you're given in the textbook. The second question is really just a Galileo's analysis of projectile motion. Which graph is it here? We've got our rotational velocity on the x-axis, so that's your independent variable, and we're measuring the time of flight. And if you have a look back at the diagram here, whatever its rotational velocity is, and therefore it's a linear velocity at the moment that it gets released, there is no vertical component of motion. So it's just like shooting something horizontally off a desk. The classic question is kind of a ramp that's horizontal at the end of the desk, and the ball is kind of released. And we're asked, how does that affect the time of flight? Okay, not the range of the projectile, but the time that's in the air. And so really the time that it's in the air is really just the time for the projectile to fall that vertical distance. It doesn't matter how far it's traveling horizontally, what its range is. It's going to be unaffected, which of course makes that answer B.